Introduction to electromagnets. An electromagnet is a type of magnet that attracts metals that attract metals that attracts metals, and when an electric current passes through it, like this, when an electric current passes through it, it is formed by when an electric current passes through it, an electromagnetic will be formed magnet that attract metals. When electric current passes through any conductor, then there will be then it will be becomes a magnetic material. So these magnetic material attract metals. When an electric current passes through it, it is formed passes through it. It is formed by cooling. It is formed when there is a wire. When after the electric current will be passing on, then the wire is automatically get heated. So then after getting the wire after getting heated, then I make a arrangement that is to be cool. It is formed by cooling. How this electromagnetic will be formed? By cooling wire around a core material such as iron or like this. The magnetic field can be controlled by adjusting the current. So this magnetic field, if I passing allowed to passing on more electricity, then the electric field is more. If I am giving a less electricity, make it available to produce passing through it less electricity, then the magnetic field will be less. Like this, the magnetic field can be controlled by the adjusting the current. So electromagnets are essential in many modern devices and technologies. Now, what are electromagnets? What are electromagnets made of? So how these electromagnets will be made of? That means there is an iron core and cylindrical iron core. When a cylindrical iron core with high magnetic permeability, so it will be also make through a electromagnetic material, and also insulating materials to prevent short circuits. How these electromagnets will be useful means insulating materials. These also useful for insulating materials, insulation to prevent short circuits and energy loss also, and coil wire. So copper wire coiled around a core to carry electric current. Copper wire coiled. There is some material is there, conducting material is there. When any copper wire coiled around it, like this, coiled around it, when a copper wire coiled around the core to carry electric current, in these yellow color coiled material allowed to be pass on a current, then it will be a electromagnetic material. So this electromagnetic material is this is formed because of the iron core, a cylindrical iron core with high magnetic permeability, and also it is a insulating materials. So insulation to prevent short circuits, it is useful to prevent short circuits and energy losses. And coil wire, copper wire coiled around the core to carry electrical current. Copper wire coiled around the core to carry electric current. How do electromagnets produce a magnetic field? So electromagnet produces a magnetic field when an electric current flows through a coiled wire. So for example, there is a one conducting material is there. If it is coiled with some other material, number of turns will be there. If these turned coil material allowed to be some electricity through this material. So already it is like this, circulating like this. So electromagnets produces an electromagnetic field when an electrical current passes through a coiled wire. This flow of current creates a swirling magnetic field. So because of these electrical elements alloying will produces some magnetic field also, which is perpendicular to the electrical field. This flow of current creates a swirling magnetic field with distinct field lines. So like this, showing like this, these distinct field lines, like this. So with distinct field lines, the strength and direction of the magnetic field can be controlled by varying current. If I allowed more current, then it produces more magnetic field. If I allowing less current, then it will be creates some less magnetic field. Similarly, the role of electric current in electromagnets. The role of electric current in electromagnets is when an electrical current flows through a coil of wire, it creates a magnetic field around the wire. Obviously, we know that the strength of the magnetic field is directly proportional to the electric current passing through it. Already I discussed. If I send more electric current, I am allowed to pass on more electric current, then the strength of the magnetic field will be more. If I am allowed to pass on less electric current, then the strength of the magnetic field will be less. Same thing, when an electrical current flows through a coil of wire, it creates a magnetic field around the wire. The strength of the magnetic field is directly proportional to the electrical current passing through the wire. The magnetic field can be manipulated by changing the amount of current. The magnetic field can be manipulated by changing the amount of current flowing through the wire, which enable the control of the electromagnetic force exerted by the magnet. The process allows electromagnets to be turned on and off, and it vary in strength, making them highly adaptable for various applications. So in addition, the direction of magnetic field can be changed by reversing the direction of the electrical current. In addition, the direction of magnetic field can be changed by reversing the direction of electric current, providing further versatility. For example, if electricity will be moving in this direction, then the magnetic field will be perpendicular to the electrical field like this. This is the magnetic field now. If electricity moving in this direction, this is the another direction. If it is electricity is moving in this direction, and what will be happens means the magnetic field will be happen in this direction. Okay, then overall the role of electric current is in the electromagnets is a fundamental. It's a fundamental thing. It's still now we are still until now we discussed about the fundamentals. So overall the role of electric current in electromagnets is fundamental, enabling precise and flexible control over the magnetic forces. Factors affecting the strength of magnets. Factors affecting the strength of electromagnets. First one, core material. The type of material used as the core influences magnetic strengths. The material what we used, that is the dependent on the strength of the magnetic output, magnetic field output. Right? In the same way, number of turns, how many turns I made, that means then the potential will be more. So more turns of wire around the core results in a stronger electromagnet. Current flow. current flow. Increasing the current flow through the wire enhances the magnetic force. Increasing the current flow through the wire enhances the magnetic force. If I increase some more electricity through the wire, then automatically the magnetic force also rises. That is already we discussed. Electricity E is proportional to magnetic field B. Electricity is directly proportional to magnetic field B. Similarly, applications of electromagnets in everyday life. Those are construction industry. In the construction industry, electromagnets are used in cranes to lift and move heavy metal objects in constructions, making it is easier and safer for workers to handle large loads. Similarly, in the healthcare sector, in a medicine, MRI machines use powerful electromagnets to create detailed images. In a medicine, MRI machines use powerful electromagnets to create detailed images of the body and internal structures for diagnostics and treatment. So electromagnets in industrial and technological settings. So for the factory and automation, electromagnets are used in assembly lines for lifting and moving heavy metal parts efficiently. They enable automated process, increasing productivity and reducing manual labor. And also in magnetic resonance imaging, MRI scanning, like this. So magnetic resonance imaging, MRI. So electromagnets in MRI machines produces strong and precise magnetic fields for medical imaging. They play a vital role in diagnosing diseases and internal injuries with high accuracy. And also mass transit systems. Electromagnets are used in maglev trains for propulsion and elevation, offering faster and smoother transportation. They contribute to efficient public transport system in urban areas. Like these electromagnets will be used in between the coaches, between the electrical coaches between the trains also, for the smooth operation, like this. And electrical generators. So electrical generators, from the core of electrical generators converting mechanical energy into electrical power, they are essential for generating electricity in power plants and renewable energy systems. So again, these electrical generators, so how the electricity will be generated in generators, the electrical generators, by the generators, how the electricity will be generated by the generators. So electromagnets from the core of electrical generators converting this mechanical energy into electrical power. So they are essential for generating electricity. What they are? So they are electromagnets. They are essential for generating electricity. Electromagnets are essential for generating electricity in power plants and renewable energy systems. So advantages of electromagnets over permanent magnets. So what is the difference between these electromagnets and permanent magnets? These electromagnets over the permanent magnets. So now, controlled magnetic forces. Electromagnets allow for adjustable magnetic forces. Controlled magnetic forces, because of the electromagnets, so we can control the magnetic forces. Electromagnets allow for adjustable magnetic force strength, while permanent magnets have a fixed strength. So by allowing the more electricity, then the intensity of magnetic field is also more. If I am allowing less electricity, then the intensity of the magnetic field is also less. So by these electromagnets allow for adjustable magnetic force strength. Like these electromagnets allow for adjustable magnetic force. If I am allowing more electricity, then the magnetic field is more. So while permanent changes, I can't adjust. While permanent magnets have fixed strength, on off capability. So electromagnets can be turned on and off by controlling the electric current, providing flexibility in applications. So applications in technology. So electromagnets are crucial in technology devices like MRI scans, which require variable magnetic fields. So energy efficiency. Unlike permanent magnets, electromagnets do not produce magnetic field when turned off. If I turned off the particular electrical field, then the magnetic field is also turned off. So unlike permanent magnets, electrical fields, but if I can't turn off or turn on the field of permanent magnets, should be always in turned on position. So unlike permanent magnets, electromagnets do not produce magnetic field when it is turned off, saving energy. This will be cause of saving energy. The challenges and limitations of electromagnets. So challenges and limitations of electromagnets. What are the main challenges and what are the limitations here? This is a heat generation. So heat generation, image query, excessive heat production and red glow industrial settings. This is a major problem. So that is image query, that is we have image here but not appearing. So image query, excessive heat production and red glow industrial settings, and size and weight. So large and heavy electromagnets contrasted with a small permanent magnet. Large and heavy electromagnets can be we can construct it with a, this is a good advantage, that is large and heavy electromagnet constructed with a small permanent magnet. For example, if I take a small magnet, by supplying more electricity, it will be act as a very it has such a capacity of magnetic field. What I am supplying particular electrical field, corresponding magnetic field will be occurs, it will be benefited. If I am decreasing here, means it will be the magnetic field will be decreases. If I am increasing the electrical field, means its magnetic field will be increases. That means there is no need of increasing any material strength and additional material. I need not to supply any more. Like this, with by using less material also, I can use more benefit as a magnetic field. So this is the thing here. Image query, large and heavy electromagnet contrasted with a small permanent magnet. Once again, large and heavy electromagnet contrasted with a small permanent magnet. So power consumption, energy consumption meter symbolizing high power usage can be done through it. Energy consumption meter, energy consumption meters, and symbolizing high power usages, all through we will get it through it. And magnetic field control, image query, complex magnetic fields, scientific and technical illustrations is there. Magnetic field control, how it is will be magnetic field control means, so complex magnetic field lines and scientific technical illustrations will be, we will get through the magnetic field. So electromagnetic face challenges related to, so what is the main disadvantage here means, electromagnet face challenges related to excessive heat. It have a facing a challenges that is related to excessive excessive heat generation, and size and weight and power consumption is more, and precise control of magnetic fields. So we have also a controlling on a particular magnetic field generation also, otherwise it will be causes to heavy damage. And addressing these limitations is crucial further advancements and broader applications of electromagnetic technology. Then future development in electromagnetic technology is enhanced magnetic strength, new material to increase magnetic force for advanced applications. There is a new material will be developed, and whatever about the nanotechnology integration, there is development of nanoscale electromagnets for highly precise control and energy efficient designs, innovative approaches to reduce power consumption while maintaining performance. Magnetic leviation systems, advancement in leviation technology for transportation and industry.